And so we provide access through a web-based interface to everything from global DEM data, like shuttle radar topography mission type data sets, all the way through to state and national scale LiDAR collections. These are airborne LiDAR primarily, down to interfaces for an individual, say, researcher or graduate student to upload like a photogrammetric data sets, like a structure from motion product produced, say, from a UAV, and archive that with us.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. The voice you heard right at the start of this episode, that was Christopher Crosby. Chris is the Geodetic Imaging Project Manager at UNAVCO, and he is also the co-founder of Open Topography. And today on the podcast, you're going to learn all about Open Topography. So let me just read what it says on the website about Open Topography, and bear in mind that I'm reading from a website, and Chris is going to explain this in a much more detailed and entertaining educational way in just a minute. But this will give you a bit of an idea about what it is and what we're going to be talking about. Open Topography facilitates community access to high-resolution earth science-orientated topography data and related tools and resources. Okay, again, I'm reading from the website, and Chris will do a much more entertaining job of talking us through what it is, what we can do with it, and what it might look like in the future in just a second. I just want to say that I had a few issues with the audio quality on my side of the conversation, so if it feels like the tone or the energy changes from time to time, it's not you're not hearing things, it's me. I've done my best to fix it through editing, and I really hope that it's acceptable. This podcast episode is sponsored by Regrid. So Regrid have recently been through a rebrand. They were formerly known as LandGrid, but now it is regrid.com. There'll be a link to this in the show notes. And if you haven't heard of them before, they are one of the leading providers of land parcel and location context data for the entire US. So Regrid does a lot of the heavy lifting. They collect, clean, and stitch together property boundaries into this sort of seamless data fabric for you. So if you are interested in understanding how US land is subdivided, owned, used, inhabited, and networked into economies and ecologies, this would be a really, really great place to start. So that's regrid.com. Jerry, the CEO and co-founder of Regrid, has actually been on the podcast before. If you want to check out that episode, it's called Polygons of Ownership, and he goes into a lot more detail about the history of subdividing land and what this is meant for land use and land ownership and some of the consequences of this. So that's worth checking out. Regrid, formerly known as LandGrid. If you're looking for parcel data for the US, this is the place to go. Hi, Chris. Welcome to the podcast. Thanks very much for this. I'm really looking forward to it. So with all podcasts, as you know, there's always a pre-interview, and I really enjoyed that conversation, so I'm looking forward to this one. And today, we're going to be talking about Open Topography. So I think before we get started, could you just introduce yourself to the listeners? And once we understand a little bit more about who you are and what you do, we'll move on and we'll talk about Open Topography.
Sure. Thanks, Daniel. It's a real pleasure to be on the podcast. I've been a big fan and have listened quite a bit over the last 6 months or a year. So it's really nice to be invited to talk about a project near and dear to me. Yeah, so I'm currently at UNAVCO, which is a nonprofit in Boulder, Colorado, that supports geodetic research and education. And we primarily have funding from the National Science Foundation, NASA, and the USGS. UNAVCO does a lot of work. Our sort of bread and butter is GNSS, so high precision positioning. But we also work with other technologies. And so I manage what we call the Geodetic Imaging Program, which is LiDAR, photogrammetry, and synthetic aperture radar. But for the purposes of the conversation today, I'm also one of the co-founders of the Open Topography project. And so I've been working with LiDAR for about 20 years with a particular focus on building tools to manage those data sets kind of in a web-based environment and to deliver the data to users in ways that are useful for the end user. My background is as a geologist, and I was fortunate to be introduced to LiDAR in the early 2000s as an intern at the United States Geological Survey. I had an advisor who was in the process of arranging for the first LiDAR acquisition ever of the San Andreas Fault. And she sort of dropped that project in my lap and said, hey, I need some help with this. I didn't have a lot of GIS background at the time and certainly knew nothing about LiDAR. So it was a little bit of trial by fire. This was early 2000s, so this was very early days of LiDAR. There was not much software support in most mainstream geospatial packages. I think we received a couple 100 million LiDAR points as ASCII files at the time. And so that was a sort of an eye-opening experience about the power of what the data can do, but also about the challenges associated with it. And then after a couple of years at the USGS, I went back to graduate school at Arizona State University to work primarily on earthquake geology. But my advisor at the time, a guy named Ramon Aerosmith, who's currently still a collaborator on Open Topography, had some funding from the National Science Foundation that was sort of at the intersection between GIS, geoscience, and kind of information technology. And that was a collaboration with the San Diego Supercomputer Center, which is a computing facility at the University of California, San Diego. And I walked in the door and said, hey, I've been working on this LiDAR stuff for the last 3 years, and it's really complicated and it's really hard. Maybe we can leverage this collaboration with the Supercomputer Center to try to do some cool stuff with LiDAR. So fast forward, we did a bunch of prototyping. We started building super crude LiDAR data processing systems that were web-based. Things like, upload an ASCII file full points and get back a DEM. We put that interface behind things like ArcIMS and tried to build interactive web-based interfaces. And through that process, kind of got the folks at the Supercomputer Center pretty excited. So, my experience working with software engineers and computer scientists, especially people at supercomputing facilities, is when you start saying things like, we have hundreds of millions of points and we need to figure out what to do with them, they get excited. And so we kind of hooked that team and did a bunch of prototyping and iterating and building more mature systems. And it became pretty clear that we were going in the right direction. There was a lot of interest in LiDAR collection for various kinds of earth science applications, things like mapping more of the San Andreas Fault, mapping landslides, mapping volcanoes. And we seemed to be building something that fit a really critical need, which was delivering those data sets to users. And so after grad school, I ended up at the San Diego Supercomputer Center, and we actually built Open Topography during that time. I spent 4 years there. And that was when we first got funding from the National Science Foundation, specifically in support of Open Topography. So that was our first funding round was in 2009. So it's been over a decade of doing Open Topography since then.
Well, thank you very much for that look into your background. I'm sure you've mentioned lots of pieces of it here, but I think it would be really helpful for the listeners. If you had to summarize what Open Topography is, what would you say? How would you describe it to someone?
Yeah, so I think it looks a little different depending on how you come at it and what background you have and what community you have. But I think generally you'd say it's an online portal or clearinghouse, or maybe you might call it a spatial data infrastructure for topographic data. And so we provide access through a web-based interface to everything from global DEM data, like shuttle radar topography mission type data sets, all the way through to state and national scale LiDAR collections. These are airborne LiDAR primarily, down to interfaces for an individual, say, researcher or graduate student to upload like a photogrammetric data sets, like a structure from motion product produced, say, from a UAV, and archive that with us. So it's essentially a clearinghouse, a place you go to find data, topographic data in particular. I think our mission statement is something like democratizing access to high resolution topography. And that's really one of the things we've done to emphasize that democratization is to co-locate the data archive with tools that you can run dynamically to generate products from that hosted data. So the goal is really to sort of abstract the basic data discovery and data processing tools from the end user and offload that processing to resources that we're running so that the user doesn't have to go and necessarily get expert in point cloud processing software or any specific GIS package if, say, they just want a hillshade image in a KMZ format they can open in Google Earth.
Okay, so now we understand that Open Topography provides hosting, it provides data discovery, and there's also functionality built on top of this. So you offer compute as well. So we can execute tasks and create derivatives based on the data that's hosted within Open Topography. And I think we should talk a little bit more about that side of things later on. But right now, I'd like to know a little bit more about the data itself. Is this a seamless data set of topographical data for the entire world? Is it based on individual data sets? Maybe you could just put a few more words around that for us.
Sure. So the continuity of the data, so to speak, really depends on where it came from. So some of the global data sets, these things like shuttle radar topography mission, there's new Copernicus DEMs, various products like that are essentially global and very homogeneous. They're standard raster resolution of, say, 30 meters. They cover most of the Earth. Maybe they don't have coverage at the very highest latitudes. And so those we treat as essentially a seamless data set. So a user can make a selection anywhere on the Earth and get back the underlying DEM data as well as derivatives derived from those data. Things like LiDAR data tend to be much more project specific. And so we tend to treat them that way. So if a data set was collected over a county in the United States, that data set gets ingested and managed kind of as a coherent block of data. It gets really messy when you start trying to stitch data sets collected from different time periods across the boundaries of the collections. As you might imagine, there's issues with coordinate systems and datums and differences in processing and difference in quality of control of the aircraft positioning that goes into sort of what the data look like and what kind of artifacts are present. So we typically manage those data sets on a case-by-case basis at the moment.
So recently we've seen formats like cloud-optimized GeoTIFF, for example. And the magic I think about a cloud-optimized GeoTIFF is you can make these range requests, so you don't actually have to host a copy of the data yourself. Does Open Topography make use of these kinds of formats, of sort of streaming data, of not hosting data? And if so, is there something similar to cloud-optimized GeoTIFFs that can be used for point clouds?
Yeah, so it's a great question. We've recently adopted the COG format, Cloud Optimized GeoTIFF format, in Open Topography. We actually took essentially our whole raster archive and converted it to COGs and made it so that our on-demand services produce COGs, in part to enable what you're talking about. So the data sit at the San Diego Supercomputer Center, and you can use things like the Amazon APIs, the CLI, and interact with those COGs and pull data out. And so in the raster space, we've done that. In the point cloud space, Howard Butler, who's been on this podcast, and some of his colleagues have been working on a new COG-like format for point clouds. I think they're calling it COPC, so Cloud Optimized Point Clouds. And I've been following the effort on GitHub, but it's definitely still in its formative stages. They're, I think, finalizing the specification. But the idea is to basically be able to do the same kinds of dynamic streaming from a static set of point cloud files sitting on disk. And so there's kind of an integrated octree type of format within those point cloud files, and then it relies on the LAZ, which is the compressed LAS format compression. So you're streaming the depth within that octree that's appropriate. It should enable a lot of really interesting things once it's complete, but it's still early days.
I also want to ask a question about what happens when we ingest data into Open Topography. So let's say I upload a file to Open Topography. Are you looking at any of the metadata? Are you doing any sort of data cleaning on the way through the process? Or is it just it comes the way it is and is accepted into Open Topography and then available to anybody who wants to access it?
So yes, there's two pathways data end up in Open Topography. There's one, which is the upload pathway, which is users uploading relatively small data sets, because you can't push hundreds of gigabytes of data through a web browser for ingestion typically. And then there's another pathway, which is like we pull the data off of some remote resource or via hard drive, and then we run it through our ingestion process on the back end. Both of those workflows, we do kind of file level quality control. So we're checking for things like, does the data set have coordinate systems set in the headers? Are those coordinate systems consistent? Are there any other problems with things like within the point cloud files, making sure the range of values in the files match the bounding box that's described in the header? Those kinds of things, the kinds of file level issues that are going to break our systems when people start making dynamic queries against the data set. The thing we're not doing, quality control of things like, are there flight line misalignments within the LiDAR data set? How good are the point cloud classifications? So, you say this point is ground. Is it actually from the ground, or is it actually a point from the vegetation that's misclassified? That level of quality control is very labor intensive. And so we don't do that. We essentially take the data as it was delivered to whoever funded it or solicited the data collection, because we hope that someone else upstream of us did some of that quality control, took delivery of the data, handed it to us, and we ingest it and make it accessible to users. So it's definitely fair to say that all LiDAR data sets are not created equal, and certainly all data sets in Open Topography are not the same. And so depending on what you're doing with the data sets, it's definitely worth looking at them, exploring them, and fortunately provide tools that make that relatively easy to do. And really trying to understand exactly what's going on. Every data set we host has a survey metadata report associated with it as well. So if you want to go back and look at how the GNSS was collected or what kind of ground control was used or those kinds of things, you can always kind of go dig into those documents.
Just out of curiosity, can I, in those documents, can I also see what platform was used or perhaps what sensor was used to collect the data?
Yes, in general, yes. So we classify the data sets by platform. Basically, is it a airborne LiDAR data set? Is it a terrestrial LiDAR data set? Was it collected from a UAV? Is it some kind of global platform that probably came from a satellite? So we have that level of distinction. But if you want to know what laser scanner was used, like was it a Regal, scanner X or a Optec Y type of scanner? Yeah, that's in the PDF reports typically that accompany these data sets.
So when you have a platform like Open Topography and you allow users to contribute their data to it, do you have to consider that this data might sort of contain culturally sensitive artifacts or perhaps things that might be considered of importance to national security? Is there any sensitivities around that side of these data contributions that you need to be aware of?
Yeah, and we're doing some of that already, actually. So the a good example is the archaeological community has really gotten excited about lidar in the last decade or so, and have started doing things like lidar surveys over places in Central America, Southeast Asia, and we have some of those data sets inside of Open Topography because the data were collected with National Science Foundation funding. But because of sensitivities about what you can see in that data and the potential for looting of sites and things like that, we restrict access to those data sets. We in general believe strongly in open data and open data access, but in these specific cases, we've been asked by the research community to provide this kind of embargo, and sort of access is a case by case. So typically people would say, hey, I'm really interested in this data set from Mexico, and we pass that request on to the original researcher who organized the data collection, and they negotiate whether the data should be open to that person or not. We haven't done this for national security or anything like that. I think some of the optical imagery out there is better in terms of seeing things than LiDAR is going to be. So, although there was an earthquake called the Ridgecrest earthquake that happened a couple of years ago over military installations in Southern California, and there were some sensitivities about those data sets. And actually, that data set does have redacted polygons in it, now that I think about it. We didn't do that redaction, but they provided a suite of polygons and the data were stripped out of the data set before it even made it to Open Topography. So I guess that does happen, but we're not the ones doing that restriction. The other place that we do apply a restriction to access is sometimes a data set gets uploaded. It was collected for academic purposes, but the research group still hasn't submitted their publication, and so we sometimes will do a temporary embargo, say until the publication is released, and then the data become open once the publication is out.
Earlier in the conversation, you talked about derivatives, so products that are being created based on the data that's being uploaded to Open Topography. What might these derivatives be?
So for data sets that start as point clouds, so that's typically LiDAR data of various forms, laser scanning data, and in some cases photogrammetric data sets. We provide everything from just like, area of interest selection on a map. So like I want data for a given bounding box. If the data set has classification associated with it, you can say I want only the ground points that are within that bounding box. And then we provide a suite of tools to do a bunch of derivative processing. So the first thing that typically people want to do is they want to create a raster from those points. So that's making a DEM of a various flavor. It might be a digital train model, it might be a digital surface model. Then things like visualization. So being able to look at the point cloud source data inside a web browser is one tool that we provide for visualization. And we also do raster-based visualization. So that's things like hill shades and slope maps. And being able to just produce those as browse images or KMZ type products. And then we have some more sophisticated processing tools. So we do hydrologic routing on top of topography. So you actually can select the bounding box, rasterize the data, and then route water over the topography and calculate contributing area and other basic kind of hydrologic metrics. And more recently, we've started working on multi-temporal data analysis. So we now provide a suite of tools to do change detection across topographic data sets if they overlap. And so this is a sort of a new area because we're getting to the point now globally where we start to see places where there are multiple data sets sitting on top of each other. And so you can start looking at change. And so we have tools to do topographic differencing now on demand, on the fly in the browser, which is pretty cool.
Yeah, and just to be clear, these derivatives that we're talking about, these are user initiated, right? It's not something that is automatically created when I upload data to Open Topography. These are tools, these are operations I can go in and run in Open Topography.
Correct. We basically provide a suite of tools with a limited set of options, sort of dialog boxes and parameters the user can change. And then you initiate the processing job and it runs on demand on compute resources at the San Diego Supercomputer Center. So it's either running on commodity clusters or in some cases, like for the hydrologic routing applications, it's running on proper high performance computing infrastructure. Open Topography, and this is important to say, is that it's a collaboration. So the San Diego Supercomputer Center is the lead institution. They're at the University of California, San Diego. They have a large machine room where we keep all of our infrastructure, all our data servers, but they also have these kind of shared high performance computing machines. And so we've negotiated to gain access to those machines. And so in some cases through Open Topography, users are running proper high performance computing jobs on dedicated infrastructure through a web browser, and honestly don't appreciate that's happening, which I think is cool, and is perhaps the power of these kinds of systems, is that you can abstract a lot of the back end and the user is just interacting with the web interface.
As a user, what do I need to do to qualify to use this? Are there any costs involved?
Nope, it's entirely free to access at the moment. We have a very generous sponsor at the moment, thanks to the National Science Foundation, and specifically the Geoscience Directorate of the National Science Foundation. So they're covering the costs of putting data into the system in general, and also the costs of the user interfacing with it. So you can use Open Topography as a totally anonymous user off the street, although we do restrict your processing limits a little bit more. If you create an account, then you have sort of full power access to access the data. So that's data download, that's this on-demand processing. We do have some partners that provide funding for data hosting, so to get their data into Open Topography. So we work with groups like Land Information New Zealand, which is the national mapping agency of New Zealand. They're in the process of collecting the whole country with LiDAR, and they're using Open Topography as their data distribution platform. So that's an example of a data partnership that we have. But from an end user perspective, it's as simple as creating a user account and exploring.
And what do you see people doing with these data sets? So obviously this was started with from an academic perspective, assuming that the scientists were going to show up and use this data to solve scientific problems. But is that what you see happening, or is there a whole plethora of use cases?
So that's still our primary use case because of the funding source. So the National Science Foundation really wants to fund novel research and also education. And so we really emphasize that as basically our role is to facilitate access to these data sets for that community. But those users represent something like a third of Open Topography's users. So Open Topography is an interesting case because it was funded for a very specific academic application, but has sort of taken on a life of its own because the power of these data sets, as I think we all appreciate, is so vast that they're useful for all kinds of interesting things beyond perhaps the original application. So, a data set that was collected to look at a landslide in Northern California or something like that has a lot of other things in it that are potentially interesting for users. And so we see that core academic user base, which represents the research community, educators, people use Open Topography in their classrooms. But we also see a lot of commercial sector users. So, various types of consultants who are doing engineering or natural hazards or urban planning are regular users of Open Topography. There's a really interesting growth in sort of virtual worlds. And so we see a lot of people who are building video games, either commercial video game developers like Electronic Arts, some of the big players, but also hobbyists who are using things like Unity to bring these data sets in and build sort of immersive visualization environments for video games or AR, VR types of experiences. We also see a lot of interesting uses in like 3D printing. People who do things like, I'm a rock climber and my favorite rock climbing spot is Yosemite Valley in California, and I'm going to go 3D print my favorite climbs. They pull data out of Open Topography. So it's really interesting. I think one of my favorite things about Open Topography is that it's a great demonstration of when you make these data sets relatively easy to use, people start doing really creative and unexpected things with them.
You talked about these different use cases, and you talked about doing 3D printing based on data from your platform, people creating virtual worlds and that kind of thing. How do you know that they're using data for that? Is there some kind? Are they referencing Open Topography? Is there some kind of reference or link back to you?
A couple different ways. One is we do have a power user opportunity, and that's by request. So you basically have to fill out a form and say, I'm requesting higher limits for data access, processing limits, and we make them tell us why they need higher limits than what we provide by default. And so that people write, a paragraph or two describing what they're doing. That's one way. We definitely get emails from groups who have used our data and want to publish it and want to clarify licensing terms or acknowledgement. And that's how I know some of these big video game companies, for example, are pulling data from Open Topography, and kind of virtual effects and video development and those kinds of communities, because they ask, like, how do we properly make sure that we provide acknowledgement for this? And then the other way is just through a lot of conversations and just one-off emails from people asking technical support questions. We also actually, if you just go Google Open Topography, you hit tons of YouTube videos from that are basically tutorials on how to go from Open Topography to Unity or some other kind of processing workflow that's in that kind of virtual world space. And so we see that, and that's kind of cool. It's cool that people are taking our resource and building their own tutorials on top of it that are specific to their workflows and their pathways.
Yeah, absolutely. But I'm wondering about if there's any tension here, right? So we've got a bunch of different use cases, and a lot of which was never the initial focus, right? It's never the reason why this project was funded. Is there any sort of tension there, or are people just generally happy that the data is being used and value is being created?
There's a bit of tension that's it's largely related to this relatively narrow funding source that has this very academic emphasis. So our sponsor, the National Science Foundation, is very excited to see broader, what they call broader impacts of their investments in things like open topography. But there's also a bit of a tension about the fact that a lot of other sectors that are not directly NSF related are gaining a lot of value and getting access to these data sets. And so that is something that we're constantly trying to navigate, is basically to build a sustainable funding model around open topography that sort of acknowledges the diversity of the user base. And so part of that has been with partnerships like the Land Information New Zealand partnership, where we work with them and they leverage our system. They cover the costs of data storage and data distribution for their data sets because they value that kind of return on investment that open topography enables. We've really tried to avoid charging the end user. That's not because we do believe in open data and open data access. But as you say, especially things like on-demand compute aren't free, and doing that at scale starts to get relatively expensive. And so we're constantly trying to figure out ways to navigate that space.
Are those kind of partnerships, do you see them as being the way forward, as providing that sort of stable business model around open topography? I guess what I'm getting at is, do you see this kind of business model, these kind of partnerships, as the way forward for something like open topography and perhaps for other projects in a similar position?
Yeah, this is a really challenging problem in the open data space. I think also in the open source software space is these things. Open doesn't necessarily mean free, especially when you're providing things like compute resources on top of data. It's relatively cheap to park data on an FTP site or dump it in an Amazon S3 bucket and let people have at it. But what we've really emphasized is this processing, these suite of tools that make the data easy to use, because we think that's really what drives greater value from the data. And what our users want is not to download, a couple hundred LAS point cloud files from an FTP site. They want contour lines derived from those data, or they want a map of change or something like that. And so handing them the raw data isn't really solving their problem. And so that's what we've emphasized, but that also doesn't come cheap. And so the case we've made thus far has largely been around this idea of partnering with groups who have a mandate to make data public. So the Land Information New Zealand is a great example of this. They're collecting the data with public funds, taxpayer money, and they have a very diverse stakeholder base. And so they want to get that data out there and enable users to have at it and do creative things with it. And so something like open topography works really well in that sort of mindset, which is instead of building something like it ourselves, which honestly, we've been working on open topography for 10 plus years in a production sense, and certainly probably 15 or more years in a sort of prototyping sense. It's really hard to recreate something like open topography, as a relatively small GIS type shop at the moment. And so it's probably more cost effective to build that partnership with somebody who's running the platform and just kind of buy into the platform and leverage it. And so that's the angle we've been pursuing, with variable amounts of success, if I'm being honest. There's a big disconnect in my view about the amount of money being spent to do things like collect LiDAR over large spatial extents in various parts of the world versus the amount of money spent to make those data accessible. And so we get a lot of emails from people asking for us to host their data for free. And that's sometimes a hard course for us to navigate, especially given that we have a single sponsor who doesn't really want to distribute data for your local state GIS office or something.
So yeah, I can definitely see a lot of good reasons for attention around some of those topics there. When you think about things like Google Earth Engine, for example, are they sort of squeezing projects like open topography? Because I guess they just sort of absorb all the costs, right? The user experience is, oh, this is free, this is effortless, this is seamless, it's integrated with everything. Everything should be like this. Are they, yeah, creating more tension around like the business model that open topography is going to need to develop to survive?
Yeah, that's a really interesting question. Google has way more resources than we do, like like wildly more. And so some of these problems they can solve very quickly, I think, and probably not care too much about what it costs. I feel like there's definitely a subset of the academic community that really uses Google Earth Engine quite heavily, and frankly, Earth Engine does a lot more than Open Topography does from a kind of programmatic access and processing perspective. But Google Earth Engine, this last time I checked at least, is still very much raster centric. And so there's not point cloud access through things like Google Earth Engine. And so that's, I think, a place where Open Topography is perhaps unique. They haven't put us out of business, but if Google Earth Engine decided that they wanted to suddenly host all the point cloud data in the world, I'm pretty sure they could do that. And I'm pretty sure that that would complicate our lives. Like they could, that would make it hard for us to write a renewal proposal to the National Science Foundation. And it would make it hard to have a relationship with a group like Land Information New Zealand if, say, Google Earth Engine was willing to take their data for free. I don't know.
So we have come a long way in the conversation. We've talked about your background, how you got involved with this project. We've talked about the hosting capabilities and the discoverability provided by Open Topography. We've talked about the kinds of processes we can execute on this data in the platform. We've even talked about the business case behind it. I'd like to move away from those things now and sort of talk more generally around point clouds. So in the last few years, we've seen this explosion in the ability to be able to collect point cloud data. What kind of challenges are we going to face in a world where we see this massive increase in the collection and maybe even demand for point cloud data?
I think there's kind of two classes of this, right? There's we've talked about the term ubiquitous point clouds, that basically they're going to be tons of point clouds coming from lots of different sources. So, the latest generations of things like the iPhone and the iPad have laser scanners built into them. And so people can start producing their own point clouds. Those data sets look really different, though, than, say, a national mapping effort, something like the USGS's 3D elevation program or the Land Information New Zealand's national mapping program. Those are relatively well-organized, quality controlled data sets. And so those probably need to be managed in a slightly different way than like these sort of crowdsourced types of data sets, right? Like there's also this proliferation of UAVs, and a lot of those UAVs are now capable of carrying laser scanners. Those laser scanners are coming down in cost. Photogrammetric point cloud generation via like a structure for motion type of workflow is exploded, and there's tons of people out building cool models of landscapes and features using photogrammetry. And then there's the whole autonomous navigation world, right? So self-driving cars, vehicles, those things are all going to be producing point clouds that they're using for positioning and navigation. So I think, yeah, there's a lot more data coming. Whether all that data needs to end up in a big kind of community archive or not is an interesting question. But I think there's a lot of interesting things you could do. Imagine like, multi-temporal data analysis of change in an urban corridor as a function of data produced by autonomous vehicles, right? You could look at how things are changing on an hourly basis, certainly a daily basis, if you had all that data in a central repository. And so that's pretty interesting and complicated about how you do data fusion and data integration when all those data sets look and feel very different. They're collected with different kinds of sensors using different kinds of technologies, and they have different accuracies and errors associated with them. So I think that's really the kind of research question for us, at least right now, is how we start doing that kind of data integration, data fusion analysis across different kinds of data sets. And we've spent a fair amount of time on this from a topographic change perspective, but most of that work thus far has been on doing change between, say, two airborne LiDAR collections, which is non-trivial. But when you start introducing things like data collected from an autonomous vehicle compared to data collected from an airborne platform compared to data collected from a UAV, that's even more complicated. Yeah, I think for sure. And the work we've done in the last year or two through Open Topography on just building tools to do topographic change, I think are pretty innovative. Not necessarily that the methodologies are particularly novel, like things like basic raster subtraction to do topographic change, or something that most people can do in their GIS environment via a raster calculator type of interface. But doing it at scale on the fly through a web browser is new, and we're doing that at the moment, and we're starting to look at what it means to take data sets at sort of the spatial scale. So, a state that's been flown by LiDAR twice in the last decade and actually computing the change of the whole state at, say, 1 meter resolution. That's a very big data problem. and we have the data access now, and we have the workflows to do it. And so that's the kind of thing we're starting to explore is that multi-temporal component. And I think that that's definitely a growth area for point cloud types of data analysis.
Yeah, I'm sure you've learned a lot during your time with Open Topography. I mean, it's a huge undertaking. There's so many different moving parts to this, and so many different stakeholders as well. If you went back in time to when you were starting out making this, what would you tell yourself? What advice would you give yourself?
That's a good question. I think some of the early efforts were very focused on point clouds and making point clouds and LiDAR types of data sets accessible through web interface. And at some point, we went back and we looked at other, actually, what I would consider more easily accessible data sets, like things like these global topographic data sets, like the Shuttle Radar Topography mission. And we put them inside of Open Topography, and we provided the same suite of basic processing tools, and we put APIs on top of them. And it exploded. Like, people were really excited about it. And it turns out that just because the data set's accessible via an FTP someplace, that extra layer of tools really makes the data exciting to people and really encourages them to use it. And so I probably would have gone back and cherry picked the obvious data sets earlier, which is there are, globally in different parts of the world, there are really good topographic data sets that may exist in raster kind of products that are at that maybe 10 to 30 meter resolution. And those, I think, benefit from an open topography style treatment, even though they're actually less challenging to deal with compared to, say, LiDAR point cloud data. So that was one lesson, that there's like some low hanging fruit that's pretty easy to pick off that we didn't go after right away that we probably could have. And then the other lesson that I think we've learned over time, and I think this was part of our culture in the beginning, but we still emphasize, is good user support and being responsive to users. And so we get a lot of emails from people who ask questions about our system, but also are asking questions about what to do with data products. Like, I want to bring this point cloud into AutoCAD or into ArcGIS or something like that. And we do it. We try to be very responsive and supportive of people. And we've done a lot of short course teaching over the years, something like 35 or 40 different short courses over the last 10 years. We're getting people in classrooms, teach them how to use Open Topography, teach them how to work with the data downstream of Open Topography in various kinds of software packages to do basic kinds of analysis. And that's really helped to grow the community as well, is to teach people about the system and kind of hold their hand, and through the initial use of the system and the basic analysis of the data has really made a difference. We've been around long enough that we've had graduate students, come through Open Topography and take a short course 10 years ago, and now they're a faculty member at a university writing papers about LiDAR data processing, or where they're using their LiDAR data processing skills. And that's pretty rewarding to see that full life cycle of training somebody, providing them the access to the data, and then seeing them go and do interesting things with it.
That's really interesting. That sort of gets back to this idea that it's not good enough just to make the data available. You've got to build other layers on top of it. That user interaction, user support, training, education. So what's interesting for the users? Like, what data sets do they want to see? What functionality are they interested in? And I think you mentioned it earlier. There was a lot of money being spent on collecting the data, but then perhaps it feels like we dropped the ball a little bit. And it sounds like that was perhaps one of the bigger lessons that you've learned, is that, okay, it's not good enough just to collect it in one place. We have to build on top of that. It's a user experience. It's a journey. It's training. It's education. That those are the things that are going to make the difference in terms of a successful project.
Yes, for sure. Like, I think those have been critical to the success of Open Topography, is that engagement with the end user community through things like short courses. Things like supporting documentation and tutorial videos are always a challenge to keep up to date, and we've done an okay job of that. We're not great at it, but we're trying to get better. But I do think that this bigger lesson from just looking at the LiDAR and sort of topographic mapping community beyond Open Topography is that I do feel like there is this imbalance between the amount of money being spent to collect data versus the amount of money available to distribute those data sets. And it's very, kind of ad hoc. Each state's doing their own. In the United States, at least, each state is doing their own thing. I think in Europe, you see the same sort of thing. Different countries have different types of data clearinghouses with different levels of functionality, everything from your static FTP, your sort of very standard FTP site, up to systems that look more like an Open Topography. And I think it's a missed opportunity. I mean, I appreciate that getting the data is really important, right? If we want to achieve national scale 1 meter topographic data, that's a huge mission, and it's cost a lot of money. But the USGS is spending something like $100 million a year in federal funds to collect these data sets. But when it comes time to distribute the data, it always feels like there's no money. And that's challenging because I think it ultimately harms the return on that investment, which is non-trivial at $100 million a year. That's a lot of money. And so spending a small fraction of that to build better user interfaces and better systems, more APIs, easier ways for people to access the data via bulk, those kinds of things are just going to drive innovation and creative utilization of those data sets.
Towards the end of these conversations, I'd like to leave the listeners with an idea of where this is going, what the future might look like for open topography. And I guess I'm wondering, is this simply going to be a case of more data, more better, or is there something else on the horizon for the future of open topography?
Yeah, I think it's two things. It's like more data, more better for sure. Like people come to open topography for the data. Ultimately, I think that's the fact that they can get the data and it's relatively easy to use and has that suite of tools is definitely the primary draw. So for us, being able to access data more globally is definitely of great interest. We have a very US centric and New Zealand centric, thanks to our partnership with Lynn's worldview. So we're open, but we're not all the topography. So, and this is a common email request as well. It's like, do you have LiDAR data covering my spot in, country X or Y? So I think trying to provide more centralized access to data sets from other places, and that's partially a funding problem. It's also partially a global culture around open data. Certain places have less open data policies than others, and that's a changing landscape and I think improving overall. But then also the other facet, I think, to the future of open topography is sort of sustainable business models around how do we do this at scale, and how do we keep building new types of tools. So this is like the multi-temporal component that we talked about, is like things like analysis across these very diverse and different kinds of point clouds and other types of geospatial data kind of in an integrated environment is definitely something that we're thinking a lot about. But yeah, I think more data is always always something that we're interested in doing. And there's been a lot of great movement in the community towards things like publishing data sets into more easily accessible resources like Amazon S3 buckets, where you can reach out and grab a data set without having to host a whole copy of the data set. And that's quite powerful for us because storage is another primary cost. And so, for example, in the US Geological Survey, working with Howard Butler, who's been on your podcast in the past, have published the 3D elevation program LiDAR data set into an Amazon S3 bucket. And then we went and built a bunch of tools to reach out and grab that data and pipe it through our processing tools. So that kind of decentralization of data, but also open access to data, is really powerful, and it enables us to do kind of federated access in a way that enables scalability and doesn't require us to make a whole copy of the 30 plus trillion points that are in the USGS's 3DEP data set.
Chris, I really want to thank you for your time. I want to thank you for your patience and for your work over the last 10 plus years, I believe, with open topography. It's much appreciated, and it's an incredible service that you offer. It's absolutely amazing. I really hope all the listeners go and check it out if they're not familiar already. Before I let you go, where can the listeners go if they want to reach out to you? Is it just opentopography.org? Is that the best place to go, or is there somewhere else that they could go to get more information or perhaps continue this conversation?
Yeah, so if you're interested in open topography, I really encourage you to go to opentopography.org. And the data tab is where most of the action is. That's where you start finding data. We have a pretty active social media presence. So if you're interested in like the latest breaking news on things happening in open topography, new data sets we've released, new features, new supporting kind of tutorial types of resources, we're on Twitter, Instagram, Facebook. Those are all just at open topography. And then my personal Twitter account, I'm marginally active on Twitter, is Crosby CJ on Twitter. And so you can also just send us an email at info@opentopography.org. And that goes to most of the team. We're a small project, so there's not that many people getting email. And one of us will get back to you hopefully very quickly, because we try our best to be very responsive to our users. So if you've got a question, you've got a suggestion, want to pick our brain about something, want to talk about collaborating on something, definitely reach out. We'd love to talk.
Thanks again. I really enjoyed talking with you.
Thanks a lot, Daniel. It's been a pleasure.
Big thank you to our sponsor, Regrid, formerly known as LandGrid. So Regrid, in case you haven't heard of them before, are one of the leading providers of parcel and location context data for the US. Regrid, collect, clean, and stitch together property boundaries for the entire US and make it really easy to get access to this. If you want to understand how US land is subdivided, owned, and used, Regrid would be a great place to start. They offer a free trial, so you can download up to 50,000 rows of parcel data for free and try it out. They have a self-serve data store, a parcel API, a vector and raster tile. So I guess the thing you should take away from this is that they have pretty amazing data and a bunch of different ways you can get at it. Regrid.com, formerly known as LandGrid. So I really hope you enjoyed that episode with Chris and Open Topography. I just want to point out that there's a lot of really amazing resources available at opentopography.org. So there's a whole lot of online training courses. There's curriculum for educators. There's an archive of all of the courses that they've done. There's also a tool registry. So if you're looking for tools to work with this kind of data, this would be a great place to look. And I think probably if you've enjoyed this episode, it might be worth checking out previous episodes that I've published. The first one I'd like to recommend is LiDAR from drones. So you won't have to go very far back in your podcast feed to find this. But I think if you're interested in collecting data from drones, this would be a great episode to listen to. And I think, again, talking about tools that we can use to work with this kind of data, you might be interested in an episode around the Point Data Abstraction Library, or PDAL. So Chris also talked about the different use cases. I think he mentioned something like 30% of all the actual use cases have some sort of scientific background. So Open Topography is being used for a lot of other things that don't necessarily involve science. And we talked also a little bit about the business case for this kind of platform. And I think if that's something that you're interested in, go back in the podcast archive and look for an episode called Access to Data, Making Room for Unexpected Contributors. This was a really interesting episode for me. It was all about giving people free, unlimited access to geocoding services. What happened when that service was made freely available to people. And my guest also tries to sort of put in a return on investment. So yeah, it costs a lot of money to do this, but what did we get out of it? And it's just a really interesting discussion about what happens when we make data freely available and make it easy to find and use and navigate. So if that's something you're interested in, again, check out an episode called Access to Data, Making Room for Unexpected Contributors. And that's it. Thank you very much for listening all the way to the end. I really appreciate your time. As always, you're more than welcome to reach out to me on social media. You can find me at Mapscaping on Twitter. You can just search for me, Daniel O'Donoghue, Mapscaping, something like that. You'll find me on LinkedIn. These are the platforms where I'm most active. And if you're interested in getting an email from me from time to time, I'll put a link to that in the show notes, or visit mapscaping.com. Okay, that's it from me. We'll talk again next week. Bye.